In this video, we are going to see about Tower of Hanoi and how to use the mathematical induction to solve this puzzle. We know that the principle of mathematical induction has two phases. If we have the statement as P of n, whatever statement we want to prove, if we take that as P of n we want to demonstrate that it is true for every n is a natural number. If we start proving that for the case 0, 1, 2, etc. k, it is not possible for us to complete if k is a large number, in which case we will be using the different step of our approach where the principle of mathematical induction initial case can be P of n. The statement or the claim, whatever we have, can be taken as P of n, which is true for every n. And we will have to prove a base case. Suppose if the initial case is 0, we have to prove that for P of 0. If the initial case is 1, we prove that for P of 1, etc. And then we prove the induction step, for which we need a hypothesis. And the hypothesis is that P of n is true when n is equal to k. And we have to prove that for the result P of k plus 1. This is the principle of mathematical induction. Let us prove the puzzle called the Tower of Hanoi. It is invented by a French mathematician, Edward Lucas, in 1883. But there are numerous myths regarding this ancient and mystical nature of puzzle, which popped up almost immediately. And there is a story about this type of puzzle in India, in an Indian temple, Kashi Vishwanath, and the puzzle is called Tower of Brahma puzzle. In this Tower of Hanoi, we have 3 pegs and a collection of discs of different sizes. Initially, all these discs are stacked on top of each other according to the size on the first peg. The largest disc is at the bottom and the smallest is on the top. A move in this game is consistent, moving a disc from one peg to the other, subject to the condition that the larger disc may never rest on a smaller one. The objective of the game is to find a number of permissible moves that will transfer all the discs from first peg to the third peg, making sure that the discs are assembled on the third peg according to the size. The second peg is used as an intermediate peg. So here we are going to claim that the total move will be 2 raised to n minus 1. The claim is that it takes 2 raised to n minus 1 moves to move n discs from the first peg to the third peg. So the base case here is n is equal to 1. If n is equal to 1, there is only one disc, so it has got only one move. And on the right hand side, it is 2 raised to 1 minus 1, which is 1, and hence it is true. For the induction step, we need to have the hypothesis, inductive hypothesis. That is, let us suppose that this is true for k. That is, let us assume that it takes 2 raised to k minus 1 moves to move k discs from the first peg to the third peg, and that is proved. Now we have to prove this for the k plus 1th move, or with using k plus 1 disc, which is 2 raised to k plus 1 minus 1. So in order to prove this result, to prove the number of moves for k plus 1 disc, let us first move the top k discs to the second peg using the third peg as an intermediate peg. Now since we are moving the K disk to the second using the third one as the intermediate, it will take 2 raised to K minus 1 moves because that is the assumption we have taken. That is the hypothesis. Now after moving this, let us use the last one, move that last one to the third peg. So the largest one is in the third peg now. Now we have to move these K pegs which we have already moved again to the third peg. So like in the beginning, we have to start using the second peg as our intermediate peg, and from the first peg we have to use the second one as the intermediate peg and move that to the third peg, and that will take 2 raised to K minus 1 moves. So finally, when we are moving these K disks from the second peg to the third peg, we will get the total number of moves as 2 raised to K minus 1, what we have used for the top K pegs, plus 1, which is the last disk we have moved to the third peg, and then again the 2 raised to K minus 1 moves for the top K disks to be moved to the third peg. So when we add them all, we get that as 2 raised to K plus 1 minus 1. And that's what we have to prove. This is the proof. So the proof of mathematical induction is a kind of recursive proof usually. Instead of attacking the problem directly, we only explain how to get a proof for P of n plus 1 out of the proof of P of n. And that's what we used here. So this video helped us to understand how to use the mathematical induction in solving puzzle like the Tower of Hanoi. Thank you for watching this video and hope this video was helpful and interesting. And thanks for all the supporters. Thank you.